Hey students, lesson 8.4 here. In this lesson we're going to learn how to multiply some special cases of binomials, and that's going to also help us to learn how to do some mental math with certain kinds of multiplication. So we're going to learn how to find the square of a binomial and find the product of the sum and difference of two binomials. So go ahead and do the review here, and I'll check back with you. All right, here's our key concept, the square of a binomial. So a square of a binomial is the square of the first term plus twice the product of the two terms plus the square of the last term. In algebraic terms, it looks like this. Basically, all we're doing is expanding the expression a plus b times quantity a plus b. And when you do that, you get a certain pattern. So if I multiply, this is equivalent to this, right? Then if I use FOIL, I'm going to do a times a, and I'm going to do outside 2 are a times b, inside 2 are a times b. So notice how we get a duplicate, and then the last 2 are b times b. So we have a squared, and then we have 2ab twice. And that's what this is saying. And if you put a minus sign in there, you get the same result, only instead of plus 2ab, you get minus 2ab. So if you can remember that, you can do some multiplications a little more easily and a little more quickly. If you don't remember that, you can just expand it and use FOIL or a table or however you want to do that. But basically what we'd be saying here is x is our a in this one. So think of this as a minus b squared. And that equals a squared minus 2ab, but x is a, so we're going to put x squared. And negative, or 7 is b, so we're going to do 2 times x times 7. 2 times 7 is 14 times x is 14x, and plus 49. Here, it's a plus b, and that's equal to a squared plus 2ab plus b squared, which is x squared. And then a and b are 9 and x, so we're going to do 9 times x times 2, which is 18x. And then 9 squared is 81. So that's the idea there. If you want to go back and just write it in expanded form and do it that way, that's fine. But eventually you'll notice that when you do it that way, so I'm going to do x times x, then I'm going to do the outside, and that's 5 times x, the inside 2 are 5 times x again. Notice we have 5 times x twice, and then the last 2 are 5 times 5, which is 25. So the shortcut is just to do x squared, then do 2 times x times 5, which is 10x, and then do 5 times 5, which is 25. So let's try that here. So I'm going to do 3n squared for the first term, and then I'm going to do for the middle term, I'm going to do minus, and I'm going to do 3n times 1, which is 3n, and then double that, so 6n. And then my last term, I'm going to take 1 times 1, which is just 1. And then I'm going to rewrite this as 9n squared minus 6n plus 1. All right, you try that. All right, let's use that idea to help us with this area problem here. To find the shaded area, what we're going to do is find the area of the big square, which is, I'll just write that out, x plus 5 squared. And we're just going to subtract the area of the inside square, which is x squared. I'm going to simplify it. I'm going to use, this looks like this form, a plus b squared. and that is a squared plus 2ab plus b squared. So my a squared, my a is x, so I'm going to do x squared. My a and b is x times 5, which is 5x times 2, which is 10x. And then my b is 5, so 5 squared is 25. And I need to subtract x squared, and x squared minus x squared is 0. So I get 10x plus 25 for my simplified expression. Go ahead, you try that. All right, let's use this idea to do some mental math. If you want, so here's what I'm thinking. I'm thinking that 49 is really just 50 minus 1. And I'm using 50 because 50 is a number that I can square in my head. So this is what I'm thinking. And this is actually this form, a minus b squared. So it's equal to a squared minus 2ab plus b squared, which in this case, a squared is 50 squared, which is 2,500. I can do that in my head. A times b is 50 times 1, which is 50, times 2 is 100. And I can do 25 minus 100 in my head, that's 2,400. And then the b squared is just 1 squared that I have to add on there, which is 1. So I have 2,400 plus 1 equals 2,401. And I could do all that mentally, as long as you recognize the form to use. Go ahead, you try that. All right, another property we are going to use here is what happens when you have the product of the sum and the difference of the same two terms. And we call this the difference of two squares. Or so when you have this situation where you have a plus b and then a minus b, well, that's equal to a squared minus b squared, and I'll just show you why here. Let's use the FOIL method, and you'll see why. So I'm going to do a times a squared, then I'm going to do outside is a times b with a minus in front of it, and the inside two are a times b with a plus in front of it, and then my last two are minus b squared. So notice that these two will equal 0, and that always happens when you have the exact same numbers, just one is a sum and the other is a difference. So if you expanded this out and did this product, you would get that, and that's just equal to that. And knowing that, you can just do this squared minus that squared to get your answer. So thinking about that, this is in that form, and that's just going to equal a squared minus b squared. So my a is x squared, so I'll put that here, x squared, and I'll square that. And my b is 6, so I'll put that here and square that, and I just get x to the 4th minus 36 for my answer. You try that. All right, let's use that idea with some mental math. Remember that to have a difference in squares, you need a number where the two numbers are added together, but you have the same two numbers and then they're subtracted. So if you think of a number right exactly in between these two, 40, I could add 2 to get this number over here, and I could do 40 minus 2 to get this number here. So I could really write this like this, 40 minus 2 times 40 plus 2. And now I can do this mentally because this is in this form. And so it equals just a squared minus b squared. A is 40, b is 2. So I can just do 40 squared. And I can do that in my head, that's 1,600. And then minus b squared, b is 2, so 2 squared is 4. So I just need to do 1,600 minus 4, which is 1,596. All right, you try that. All right, we're up to the lesson check here. Go ahead and do that, and I will talk to you about this the next time we meet in class.